Hello, everyone, and welcome back. I am Dr. Supradip Das, Assistant Professor at the Department of Design, IIT Guwahati, and this is the 24th lecture of the course Introduction to Toy Design. In today's lecture, we will discuss two important aspects of toy development. One, the process for designing a toy, and two, the process for redesigning a toy. Although both processes are connected, they serve different purposes. Designing creates something new. Redesigning improves, adapts, or reimagines something that already exists. By the end of this lecture, you will be able to understand the stages of the toy design process, including user research, concept development, prototyping, material selection, safety considerations, and testing. Second, learn to apply child-centered and age-appropriate design principles while designing, while integrating safety, ergonomics, play value, and sustainability into toy concepts. Third, understand existing toys critically to identify design gaps related to usability, durability, safety, inclusivity, or environmental impact. And fourth, you will learn to develop a structured redesign strategy incorporating improvements in material choice, regulatory compliance, longevity, functionality, and cultural relevance. So in the first section of this lecture, we will explore the design process of designing toy. Look at context-specific considerations within the design process and review case studies that highlight special factors involved in designing toys. Before exploring toy design process, let us understand what is process and what is design process. What are the core purpose of design process? A process is a series of connected steps or actions carried out in a particular order to achieve a specific goal or outcome. And design process? Design process is a structured sequence of steps that designers follow to identify a platform, develop ideas, and create effective solutions. It is not random creativity. It is systematic, iterative, and goal-oriented problem solving through design. Now, let me question you. What is the purpose of design process? So, the core purpose is to understand the user, to define the problem clearly, to explore multiple creative possibilities, to test and refine ideas, and to produce a functional, safe, and meaningful outcome. Let's dive into the design process for designing toy. The generic design process used for industrial design is also used for designing toys as well. Now let us understand the design process through IDEO's approach, which is one of the most influential design methodology to do the process. IDEO is a design and consulting firm with offices in the US, England, and China. It was founded in Palo Alto, California in 1991 by David Kelly, Bill Morridge, and Mike Natal. In IDEO's approach, design process can be understood in 5 key stages, which are empathy, define, ideate, prototype, and test. In the next slides, let us understand the process stage-wise. Stage 1, empathy. It is about understanding the audience, which is the child for whom we are designing. Toy design begins with deep observation and engagement. The designers will study how children play, age-specific developmental needs, cultural context and family environment, and safety and behavioral patterns. For toys, this means observing how children hold, drop, chew, twist, or imagine with objects. Empathy ensures the toy supports real play behavior, not just adult assumptions. Stage 2, define. It is framing the design problem, focusing questions based from the insights gathered from the empathy stage. For example, how might we design a toy that enhances fine motor skills for toddlers? How might we create a culturally rooted toy using sustainable materials? This stage ensures the toy is not just decorative but purpose-driven, addressing learning, safety, durability, or emotional development. Stage 3, ideate. In this stage, it is about iterating multiple concepts. Designers brainstorm and ideate different concepts creatively through sketching different forms, exploring material options like wood, silicone, bamboo, etc., considering mechanical safety and regulatory constraints, and testing open-ended versus structured play formats. At this stage, quantity of ideas matters before narrowing down to finalize one final concept to work on. Stage 4, prototype. In this stage, designers represent one or two design ideas or concepts from stage 3. Prototype is important because this stage allows to check if the ideas or concepts works or not. Toy design heavily depends on prototyping. Designers create low-fidelity models with cardboards, clay, foam, material mock-ups, functional samples. These prototypes created are tested carefully to ensure they meet functional and safety standards such as durability, which is drop test, and compression, child interaction such as grip size and chewability test. Safety test is for no sharp edges and no choking hazards. Also, at this stage, iteration of model making is critical. Toys often go through multiple refinements before finalization of design. Stage 5, test. Once the prototype is developed and internally tested, it is introduced to the actual users, that is children and their parents. At this stage, the initial design ideas are put into real-world contexts, allowing designers to observe authentic interaction and behavior. Designers carefully study: does the child engage with the toy naturally and intuitively? Does the toy sustain repeated use without breaking or deforming? Does it remain safe under foreseeable misuse, such as dropping, pulling, biting, or twisting? These observations generate valuable insights. Feedback from both children and parents often leads to refinements in size, proportion, material choice, functionality, and aesthetic appeal. This stage reinforces that toy design is not linear but iterative. Continuous testing and refinement ensures that final product is safe, durable, meaningful, and developmentally appropriate. The toy design process is a multidisciplinary process that integrates child development, safety, engineering, cultural awareness, sustainability, regulatory compliance, and creative innovation. A well designed toy is not only engaging, it is safe, durable, meaningful, and socially responsible. When designing a toy, multiple interconnected considerations guide the process. Let us look at the considerations. Child centered considerations focus on age appropriateness and aligning the toy with a child's motor skills, cognitive level, and emotional maturity. Ergonomics such as grip size, weight, and proportion ensures comfort and usability. Toys should also support developmental goals like fine motor skills, problem solving, imagination, and social interaction, while remaining inclusive, gender neutral, culturally sensitive, and supportive of neurodivergent children. Safety considerations remain the primary principle in toy design. Toys must have no sharp edges or small detachable parts that pose choking hazards. Material must be non-toxic and compliant with standards such as IS 9873, EN 71, or ASTM F963. Electrical safety and flammability resistance are equally critical where applicable. Material considerations include the use of sustainable and eco-friendly materials such as wood, bamboo, natural fibers, or certified safe plastics. Durability and longevity are essential so the toy remains safe over time. Non-toxic paints and finishes along with thoughtful tactile and sensory qualities enhance both safety and engagement. Cultural and contextual relevance ensures that toys represent local stories, craft, and identities while avoiding harmful stereotypes. It should reflect community values, respect religious or symbolic elements, and act as meaningful cultural transmitter and functional considerations. Cultural and contextual relevance ensures that toys represent local stories, crafts, and identities while avoiding harmful stereotypes. It should reflect community values, respect religious or symbolic elements, and act as meaningful cultural transmitters. Functional considerations address whether the toy supports open-ended or structured play, offers intuitive interaction, and allows multifunctionality. Portability and ease of storage add practical value for families. Environmental impact considerations must also be evaluated through life cycle thinking, focusing on biodegradability, recyclability, minimal packaging, and reduced carbon footprint. Regulatory compliance considerations ensures that toys meet national and international safety standards before entering the market. Designers and manufacturers must adhere to applicable regulations, conduct required testing, and obtain necessary certification. Compliance is not just a legal requirement, but it ensures that the toy remains safe under foreseeable use and misuse conditions throughout the life cycle. Manufacturing and cost feasibility considerations. A well-designed toy must also be feasible to produce. This involves selecting appropriate production methods, whether handcrafted or industrial, and evaluating scalability for larger markets. Cost effectiveness should never compromise safety, durability, or material integrity. Ethical sourcing of materials and fair labor practices are equally important, ensuring that the toy supports responsible production systems while maintaining quality and affordability. And aesthetic and emotional considerations appeal plays a key role. Thoughtful use of color psychology, form, character, design, storytelling, and emotional connection ensures that the toy is not only safe and functional but also deeply engaging and memorable for the child. Based on the considerations discussed, now let us look at different design process that is integrated while designing, for example, sustainable futures, special need consumer, and socio-cultural. With the rapid progress of social and economic development, sustainability has become a central concern in design practice. Green design is no longer optional. It is essential. As a significant sector within product design, toy manufacturing must actively embrace sustainable principles to support environmental protection, economic resilience, and social well-being. Here, we will look at the different aspects of sustainable toy design process. The diagram presents sustainable toy design elements organized into three interconnected layers. The first layer is child-centered foundations, core design and production factors, and life cycle and environmental impact. At the center of sustainable toy development is the child. The design must respond to children's developmental stages, their motor skills, cognitive ability, and emotional maturity. Alongside this, the physical properties of the toy is weight, size, texture, and usability must be incorporated, must be appropriate and supportive of safe interaction. The second layer focuses on core design and production factors. Material selection is crucial. Toys must use non-toxic, renewable, or recyclable materials. The manufacturing process should reduce environmental impact while maintaining quality. Safety remains the primary principle. Toys must be free from hazards and comply with national and international standards. Durability ensures the toy remains safe even after repeated use, and versatility enhances long term play value by encouraging creativity and multiple forms of interaction. And the third layer extends sustainability across the product's life cycle. Packaging should be minimal and environmentally responsible. Recyclability ensures that the toy does not become waste at the end of its use. Finally, the broader effects, environmental, social, and developmental, must be considered to ensure the toy contributes positively to both children and the planet. Now let's look at the sustainable materials and processes in toy design. This process explains the sustainable toy design process as a holistic and interconnected system. At the foundation are three key pillars: population, materials, and methods. Population refers to the user, primarily children, whose developmental needs must guide the design. Materials refer to safe, sustainable, and resource efficient choices. Methods refer to responsible manufacturing processes. At the center of the model is sustainable toy design, surrounded by three interconnected stages: conceptualization, materials, and manufacturing. During conceptualization, designers understand children's cognitive, physical, and emotional development. In the material stage, careful selection of non-toxic, biodegradable, and renewable materials ensures safety and environmental responsibility. And in manufacturing, production processes must maintain quality while minimizing environmental impact. The process also includes internal and external dimensions. Internally, designers focus on safety, functionality, adaptability, and recyclability. Externally, they must understand target demographics, consumer behavior, market testing, and feedback mechanisms. And in manufacturing, production process must maintain quality while minimizing environmental impact. This process also includes internal and external dimensions. The internal design considerations focuses on core design decisions, understanding children's cognitive, physical, and emotional development, selecting non-toxic, safe, biodegradable materials that conserve resources, ensuring toys are functional and adaptable in different play scenarios. Designing for manufacturability, use, and recyclability. These are designer-controlled factors embedded within the product, that is toy. And external considerations highlights broader system factors, targeting the right demographic, understanding consumer motivations and decision making, market testing, establishing feedback mechanism and improvements. These ensures sustainability aligns with real-world market conditions and user behavior. This process highlights that sustainable toy design is not only about eco-friendly materials. It is about integrating user needs, production system, and life cycle thinking into continuous improvement process. So sustainability is achieved when the toy remains safe, functional, durable, and environmentally responsible from concept to end of life. And sustainable toy design reflects system thinking approach where social, environmental, and economic factors intersect. Sustainable development positively impacts both industrial and society by balancing environmental protection, economic growth, and social responsibility. In the context of toy manufacturing, sustainability influences not only how toys are produced, but also how they affect the planet, communities, and future generations. Sustainable toys contribute to environmental conservation, social well being, and responsible industrial practices. Their effects can be understood through environmental, economical, and social dimensions. 1. Environmental effects on sustainable toys. Environmental sustainability is central to the future of toy manufacturing. Sustainable toy production focuses on minimizing ecological damage while ensuring long-term resource availability. The key environmental impacts are reduction of carbon footprint, energy efficient and resource conservation, safer material use, waste reduction, and circular systems. Given rapid urbanization, population growth, and increasing consumption patterns, environmental sustainability has become a major global challenge. Sustainable toy design supports ecological balance and safeguards resources for future generations. 2. Social effects of sustainable toys. Sustainability extends beyond environmental protection to include social responsibility and community well-being. Key social impacts are child health and safety, responsible production management, regulatory enforcement, industry responsibility, and innovation, public awareness, and ethical consumption. Social sustainability ensures that toy production promotes safe childhood experiences while supporting ethical industrial practices. And 3. Economic effects of sustainable toys. Sustainability encompasses not only environmental and social dimensions, but also economic sustainability. As global economies grow, consumer demand for green and responsibly designed products continues to increase. Key economic impacts are growth of green markets, green technology innovations, competitive advantage, sustainable consumption patterns, balancing profit and ecology. Sustainable toy manufacturing demonstrates that economic development does not need to conflict with environmental protection. Instead, green innovation can drive long-term profitability while supporting ecological stability. This image illustrates the 4 stages of the toy product life cycle, which align the principles of life cycle assessment. Life cycle assessment evaluates the environmental impact of a product from raw material extraction to final disposal, supporting sustainable design decisions in the context of children's toys, which typically have short lifespans. The life cycle is simplified into 4 key interconnected stages. 1. Toy product production stage. This stage includes raw material extraction, material processing, and manufacturing and assembly. According to LCA methodology, this phase significantly influences greenhouse gas emissions, energy consumptions, and material waste. Sustainable design at this stage emphasizes material reduction, use of recyclable or biodegradable materials, and energy efficient manufacturing processes. Design decisions made here determined much of the toy's overall environmental footprint. 2. Toy product sales distribution stage. This stage involves packaging, transportation, and market distribution. Environmental impact arises from logistics, fuel use, and packaging waste. LCA helps assess carbon emissions linked to distribution systems. Sustainable strategies include minimal and recyclable packaging, local sourcing, and production and efficient supply chain management. 3. Toy product use stage. The use phase considers durability, safety, and functional lifespan. Since toys often have short usage cycles, durability becomes critical in extending product life cycle. A longer lifespan reduces frequent replacement and lowers overall environmental impact. LCA evaluates energy or maintenance requirements, wear and tear, and user behavior patterns. Designing adaptable and versatile toys increases sustainability during this stage. And 4. Toy waste management stage. This final phase includes disposal, recycling, recovery, and landfill impact. Traditional design followed an end-of-life model. However, sustainable toy design replaces this with circular strategies such as recyclability, material recovery, and reuse systems. In the sustainable toy design process, it must consider the entire life cycle, from production to disposal. Further, this stage presents an overview of the complete life cycle of a toy product using a circular or looped system of life cycle assessment and circular design thinking. It highlights 6 interconnected stages, emphasizing that product development is not linear but continuous. The arrows forming a loop indicates that end of one stage influences the beginning of the next, promoting sustainability and material recovery. The life cycle assessment process has 6 stages. Now let us understand each stages. Stage 1, raw material stage. This is the starting point of the toy's life cycle assessment, which includes extraction of natural or synthetic resources and selection of renewable, recyclable, or biodegradable materials, etc. Sustainable design decisions at this stage significantly reduce environmental impact by lowering resource depletion and carbon emissions. Stage 2, material processing. Raw materials are transformed into usable forms, such as refining, treating, or converting materials that leads to energy consumption and emissions occurring here. Sustainable strategies focusing on minimizing energy use, reducing waste, and avoiding toxic chemicals. Stage 3, manufacturing. This stage includes production and assembly of toy components, quality control and finishing, eco-efficient manufacturing methods, reduced waste, and safe working conditions are essential for sustainable toy production. Stage 4. Transportation. After manufacturing, toys are transported to markets, which includes the steps of packaging, distribution, logistics, which leads to fuel consumption and carbon emissions. Here, sustainability efforts aim to reduce transportation distances, optimize packaging, and improve supply chain efficiency. Stage 5. Sell or use. This stage represents retail and consumer purchase. The toy's functional lifespan and user interaction and durability. Durability is critical here. A longer lasting toy reduces the need for replacement by lowering overall environmental impact. And stage 6, end of life. This final stage includes disposal, recycling and reuse or material recovery. Instead of following a traditional take, make, dispose model, sustainable design encourages circular strategies such as recycling and repurposing materials, which then feed back into raw material stage. The circular life cycle approach ensures that environmental responsibility is embedded from the very beginning of product development to the end of life recovery. To assess the LCA, there are different softwares such as SEMA Pro, Gavi, Sphera, EcoChain, OneClick, and OpenLCA. One can try any of these to assess LCA for toy design. In the special needs consumer toy design process, we are taking the as example of children with autism between the age of 2 to 6 years, which is widely considered the most effective developmental window for early intervention and therapeutic support. During this critical period, children are highly responsive to structured learning, sensory engagement, and emotional guidance. Here is a structured toy design process specifically adapted for autistic children. This process integrates user-centered developmental understanding, safety and regulatory compliance, iterative validation, and testing. The toys are carefully designed to meet both the developmental needs of children and the practical expectations of parents. Through thoughtful use of form, color, modular construction, and interactive technology, the toy supports emotional learning, personalization, and creative expression. Let us understand stepwise. Step 1. User understanding and developmental research. The process begins with deep understanding of autistic children aged 2 to 6 years, a critical early intervention stage. Design research focuses on communication challenges, emotional recognition difficulties, sensory sensitivities, motor skill development, and parent-child interaction patterns. And consultation with therapists, parents, and educators ensures the toy responds to real developmental needs rather than assumptions. Step 2. Defining core therapeutic objectives. Based on research, 3 primary objectives are identified. emotional expression and recognition, adaptive and modular engagement, and creative and sensory self-regulation. These objectives guide all design decisions. Step 3. Concept development. One of the core features developed is emotional recognition and communication. The toy is conceptualized as a cube. Example, each of its four sides displays a common childhood emotional expressions such as happy, sad, angry, and scared. During play, children select the facial expression that reflects their current emotional state. This provides a non-verbal communication bridge between child and caregiver. This feature supports emotional recognition, emotional labeling, and safe expression of feelings. By transforming emotional learning into playful interaction, children gradually build awareness and confidence in expressing emotions. This stage also look into conceptualizing a toy that is modular, personalized, and adaptable, allowing the toy to evolve with the child's development, extending its lifespan and maintaining engagement. Creative painting space with smart integration, such as allowing children to paint or draw freely or express emotions visually, and material selection and safety compliance prioritizes non-toxic, child-safe materials, where safety remains the primary principle at every stage of design. Step 4. Prototyping and sensory testing. Prototypes are developed and tested for durability, grip comfort, and ergonomic suitability, sensory response such as texture, color sensitivity, and overstimulation, avoidance, and emotional clarity of facial expressions. Observation sessions with children and caregivers help assess real-world interaction. Step 5. Iterative validation and refinement. Here, feedback is gathered from parents, therapists, and early childhood educators. And based on the feedback, design refinements are made in size and proportion, emotional clarity of visuals, structural stability, and digital integration usability by doing multiple iterations. It ensures the toy remains developmentally effective, safe, and engaging. Now let us look at the design process, considering how cultural aspects are understood in the toy design process through the process of the cultural product design model. As we live in a world shaped by a global marketplace, while markets are moving towards globalizations, design practice increasingly emphasizes localization. Business must therefore think globally in terms of strategy and competition, but act locally in design execution. Many products in the global market are becoming similar in function and form, leading to loss of distinct identity. Incorporating local cultural features into product design helps differentiate products in a competitive global environment. Cultural product design is a process of rethinking or reviewing cultural features and then redefining the process in order to design a new product to fit into society and satisfy consumers with culture and aesthetics. Cultural toy design is a process consisting of three main components: the conceptual model, the research method, and the design process. The model provides a structured way to transform cultural elements into contemporary toy design. It helps designers systematically extract cultural meaning and interpret into tangible products. The conceptual model focuses on understanding culture as a source of design inspiration. It begins with cultural objects such as artifacts, crafts, symbols, rituals, architecture, folklore, or traditional practices. The aim is to identify meaningful cultural features embedded in these objects. These features may include visual elements such as patterns, colors, motifs, functional characteristics, symbolic meanings, and stories and values. The conceptual model then guides designers to transfer these extracted cultural features into a structured design model. In other words, it bridges the gap between the cultural heritage and contemporary toy development. In research methods, it consists of three systematic steps, which are identification, translation, and implementation. Step 1. Identification. This is the analytical stage. Designers study original cultural objects to identify distinctive cultural characteristics. These may involve field research, documentation, interviews, literature review, and observation of traditional practices. The goal is to clearly define that cultural elements are unique and meaningful. Step 2. Translation. In this stage, cultural features are transformed into design information. For example, a traditional motif becomes a surface patterns. A cultural story becomes a narrative-based play concept. And a ritual function becomes an interactive mechanism. Here, abstract cultural meanings are translated into tangible design elements such as form, color, material, structure, or interaction style. And the final step is implementation. The translated cultural elements are integrated into the actual toy design process. Designers develop prototypes, refine forms, select materials, and produce final cultural toy. At this stage, cultural identity becomes embedded within the product's physical, functional, and emotional qualities. And in design process, the cultural toy design model ensures that cultural features are not superficially applied but thoughtfully integrated throughout the design process. It creates a structured pathway from cultural analysis to design interpretation and to product realization. This model supports innovation while preserving cultural authenticity. Based on the cultural toy design model, the cultural product is developed through scenario building and storytelling strategies. In practical application, the design process follows four key stages: investigation, interaction, development, and implementation. Now, let us understand each stages in details. 1. Investigation set a scenario stage. The first step is to identify key cultural features from the original cultural object. These features are analyzed across three levels: the outer tangible level, the middle behavioral level, and the inner intangible level. A scenario is then created that considers the broader context, including economic conditions, social culture, and technological factors. This stage helps determine which cultural elements are most essential to represent in the final product. 2. Interactions. Tell us a story stage. Based on the scenario, the second stage focuses on user-centered observation. Designers explore the social and cultural environment to define a toy that carries meaningful cultural identity. This stage involves interaction between culture and technology, dialogue between users and designers, and understanding user needs within their cultural context. Storytelling is used to describe user needs and shape the product's cultural character. 3. Development. Write a script stage. In this stage, ideas are developed into concrete design concepts. Designers create sketches, visual representations, and written concepts based on the scenario and story. The scenario and narrative may be defined during this process to ensure logical consistency and meaningful cultural translation. This step clarifies why the product is needed and how it fulfills user expectations. 4. Implementation. Design the product stage. The final step translates cultural features into the actual product. Designers organize identified cultural elements into the structured framework or matrix to ensure they are properly integrated. The prototype is then evaluated in terms of product features, cultural meaning, and overall appropriateness. Based on feedback, modifications are made and further testing is conducted. Now let us look at some of the case studies with special consideration in designing toys. We will understand the design process of the therapy toy by Renate Muller. Therapy toy by Renate Muller is one of the special consideration in designing toy. She developed her therapeutic play object through a process that combined craft practice, material experimentations, and close collaboration with therapists and children. Her approach was not a conventional industrial toy design method, but a practice-led, user-centered, and therapeutic design process. Here, the design process she used includes observation of therapeutic needs, material-centered exploration, form development through function, prototyping and iterative testing, durability-focused refinement, emotional and sensory integration. Let us understand the process in detail. First, observation of therapeutic needs. Muller worked closely with child psychologists, occupational therapists, special educators, and children with physical and cognitive disabilities. Instead of starting from aesthetics, she began by understanding sensory needs, motor skills, limitations, emotional and behavioral conditions, and therapeutic goals. Second, material-centered explorations. Here, the method is hands-on material experimentation. Materials are explored by iterating which material suits which therapy. Some of the materials explored are jute and natural fibers, textiles, their durability, suitability for soft but structured forms, and tactile surfaces. And these choices of material were critical because therapy toys must stimulate sensory engagement, be safe and non toxic, and withstand intense physical interaction. Third, form development through function. Here, form is being iterated instead of designing figurative toys with rigid details. Iteration is more about simplified animal-like forms, large, soft, sculptural bodies, and minimal facial features. These allowed children to project emotions and imagination freely. The toys become open-ended therapeutic objects, not prescriptive characters. Fourth, prototyping and iterative testing. Toys were prototyped and tested directly in therapeutic environments, and design refinement happened through observing children's interaction, feedback from therapists, and adjustments in size, weight, texture, and structure. This iterative loop also ensured functionality and durability of the toy. The next topic is the process of redesigning toy design. Let us first look at the redesign process strategy that considers technical and performance improvements and contextual and cultural improvements. In the technical and performance redesign strategy, it focuses on improving the toy's physical and regulatory aspects, enhancing safety, material sustainability, durability, and regulatory compliance, which includes sustainable and safe material selection, regulatory compliance, such as BIS, EN 71, durability and longevity testing, structural strength and mechanical safety, chemical safety and non-toxic finishes, and improvement functionality and user ergonomics. And in contextual and cultural redesign strategy, it focuses on improving the toy's social, cultural, and experiential value. By improving functionality, cultural relevance, and user engagement, that includes cultural relevance and storytelling, age appropriateness and developmental alignment, inclusivity and accessibility, aesthetic adaptation for contemporary users, sustainability, narrative and ethical sourcing, transparency and user engagement, and play value enhancement. Now let us understand the redesign of toy design process based on the case study of Gilli Danda by Bhavna Nagpal et al. In this methodology, concepts were generated for both with a common goal of how these can be brought back to the mainstream and appeal to the children today. Out of the developed concepts, final concept was selected based on various parameters and develop a final concept keeping in mind the specifications for manufacturability, point of purchase, and market scope. Stage 1. Research, which includes studying what are the issues in the industry specific to India. Stage 2, which is concept development. A specific toy is selected, for example, Gilli Danda, and problems and reasons were identified through research and observation as to why Gilli Danda has been forgotten over time. Gilli Danda was once an outdoor game crafted from discarded wood found on the streets or made from tree branches. Today, with shrinking urban spaces, limited access to raw wood, and fast paced lifestyles dominated by video games, both making and spontaneously playing, the game have become increasingly difficult. Further, concepts were sketched to redesign, and using the weighted ranking method, the final concept was selected. For weighted ranking method, the parameters are ease of use, that is ergonomics and understanding, storing, maintenance, and manufacturing process. It is done keeping in mind the toys should not only be appealing but also good for business to be able to bring into the mainstream. The redesigned concept here is inspired by the telescopic mechanism, that is collapsible and can be carried around easily. This is done to encourage kids to play and make it an anytime toy. The following are the advantages. 1. Telescopic tube-like structure, when expanded, becomes the danda, which can be held at the broader end to play the game. The gilli can be stored in the tube itself when it is closed completely. A rubber cap is provided to prevent it from falling off. In the concept generation phase only, material and manufacturing aspects were considered. The manufacturing can be done with plastic. In this case, it can be high-density polyethylene plastic, as it is safe and can be light for kids to play. The cap is to be made of rubber, as it is easy to remove. The process that will be used to make the toy is extrusion molding, similar to the manufacturing of plastic tubes. These specifications were taken after studying the safety standard of toys in BIS, IS 9873 and ASTM F963. Stage 3 is prototyping and development. In this stage, virtual prototyping is carried out in details to consider materials and manufacturing processes. The redesign process further proceeds with branding, packaging, and point of purchase design. We came to know about different types of toy design processes. The toy design process is not fixed. It is not linear. The process can be as creative and playful as the designer is. It can start from a mechanism also. For example, this particular toy. In this, a pullback gear is used simply inside this hemisphere. The design is done in such a way that the pullback gear mechanism fits perfectly inside the toy, and if we push back, it goes, if we pull back, then it goes forward. Similarly, in this toy is designed taking inspiration from mechanism. Similar to the pullback gear mechanism. So here the action taken into consideration is into reverse direction. Instead of pulling back, the push mechanism is used. However, the mechanism is same. So two different toys we can see here that is inspired from mechanism. As we understood from the process for designing a toy and the process for redesigning a toy, it is important to reflect beyond the steps and stages. Designing a toy is not just about creating something new, it is about shaping childhood experiences. Redesigning a toy is not just about improvement, it is about responsibility and responsiveness to change. Before we end today's lecture, let us leave ourselves with a few questions for thought. Are we designing toys merely to sell? Or are we designing them to shape a better future? So, see you in the next lecture. Till then, have a playful time.